In this video, we'll just be looking at more examples of the comparison test. So you'll notice that this is the series that we want to determine whether or not it converges or diverges. For this one, you'll also notice that it starts at 4 and not at 1. That's not going to affect our ability to do this particular problem. You'll notice that it has to start at 4 because if I started anything below 4, I'd have either 0 in the denominator or a negative in that radical. So again, for us to use the comparison test, when I plug in 4 and every other value, I'm getting positive numbers that have to be, again, simply greater than 0 and have to be defined. So what's important to notice this one here is that the comparison I might want to make is that this looks very similar to that of the simply 1 over the square root of k. Now, for us to make this comparison and feel comfortable with this comparison, we might want to actually start off by thinking about how the square root of k will compare to the square root of k minus 3. Again, the reason why I'm going to compare this is because I know how these things will actually behave. Well, maybe this is too difficult for us to compare. Maybe it'd be easier for us to compare just this. This is a good start. I know that this value will definitely be larger than this value. Guaranteed. So if this is, say, 16 and this one here is 4, if I square root this one and I square root this one, the k will still be larger. So by adding the square root to both sides, it shouldn't change that inequality symbol. Now let's talk about how we're going to flip the inequalities. So I want this to be the square root of k, and I want this to be, 1 over the square root of k, and I want this to be 1 over the square root of k minus 3. I can't simply just flip both fractions and assume the inequality will necessarily hold. Actually, what's going to happen is I'm going to multiply both sides by 1 over the square root of k, and that'll put this one as a 1, and this one will now have a 1 over k in the denominator. I'll do the same thing with the 1 over the square root of k minus 3. It will actually end up being basically like I'm multiplying both sides by a denominator that wasn't ever there, and it's not going to flip the inequality because multiplying both sides by multiplying both sides by a positive number doesn't change the inequality symbol. So I end up with something that looks more like this, and again, I'm doing this by simply multiplying both sides by 1 over the square root of k, and multiplying both sides by 1 over the square root of k minus 3. So then I have this conclusion of the inequality. So before I even move on from this, I'm going to go ahead and identify some very clear information, at least get some understanding of the comparison test. Because this series is smaller than this one for every single term, and this one was the one I'm bringing to the table, this is the one I have to make a conclusion about. It's also important that if this one converges, then I know nothing about this one, because it's less than it. Now again, if you're struggling with the understanding of that, the idea is if I have b sub k terms down here, and I have a sub k terms up here, and if this thing converges based on all these terms adding up, approaching to a specific number, then this one doesn't have anything to tell it what to do. Again, it doesn't have anything to tell it what to do. However, if b sub k starts to increase uncontrollably and rapidly, and I know for every single term a sub k has to be above it, well then if this one, when I add up all the terms, goes off to infinity, then this one then also has to add up, going off to infinity. So the idea is if I can prove that this term right here inside of a series, so let's go ahead and say, so the sum of k equals 4 to infinity of 1 over the square root of k diverges, and I do know it diverges by a p series, okay, because this is specifically 1 over k to the 1/2, and my p value is again specifically between 0 and 1. I know that I have divergence for a p series. So given that I know that this p series diverges, and with this detail up here, this implies, by the comp test, again, comparison test, if we don't state comparison test, I don't know how you're making the conclusion of how these things are convergent or divergent, so it's important that you tell me not only the qualifying mathematical detail, it's important that you tell me how the series you brought to the table is convergent, and then it's important to identify which test you're using, because there are multiple tests that have you compare in some way. So then, because this is true, the series I brought to the table is smaller than this one, and because the series that I brought to the table is divergent, by the comparison test, the series that I was asked to deal with, from 4 to infinity, of 1 over the square root of k minus 3, is then also divergent.